All right, next we're going to be answering two example problems. The first one asks us to find the horizontal asymptote, if any exists, find any points of discontinuity, then graph. So we're going to take the five-step approach that we just talked about in the notes in order to do this. Step one was your horizontal asymptote. So the horizontal asymptote here, remember we need to look at our leading terms. Our leading term in the top is 3. That's the same as saying 3x to the 0. So if we're looking here, we've definitely got a larger degree in the denominator. Because we have a larger degree in the denominator, that's going to mean that our horizontal asymptote is at y equals 0. And we can go ahead and we can plot that in our graph. So we've got this y equals 0 horizontal asymptote. Step 2 was factoring. We need to factor the numerator and we need to factor the denominator. Since the numerator is just 3, we can't actually factor that any further. But we can definitely factor the denominator. The denominator is a trinomial, which means that I'm probably going to be using Xbox factoring to factor this. All right, so Xbox factoring states we've got a negative 12 at the top because that's our C value. We've got a negative 1 at the bottom because that's our B value. And we need two numbers that multiply to equal negative 12 and add to equal negative 1. I'm thinking 3 and 4 are going to be our numbers, and then 4 needs to be negative in order to get a negative 1. So 3 minus 4 is negative 1. That means that our equation is now y is equal to 3 divided by x plus 3 multiplied by x minus 4. Okay. Step 3. Step 3, we need to figure out our zeros. So I'm going to set my numerator equal to 0 first. That's going to help me find my x-intercepts. So my x-intercepts is where my numerator equals 0. So I'm going to do 3 equals 0. Because 3 can't equal 0, that would be bad math. We have none. We don't have any x-intercepts. The next thing we want to do is figure out our discontinuities. So I'm going to set my denominator equal to 0. That's going to be x plus 3 multiplied by x minus 4 is equal to 0. Now remember that when we're setting two factors equal to 0, if either factor equals 0, then the entire thing equals 0. So I can set each one individually equal to 0 to figure out when that occurs. So x plus 3 equals 0 and x minus 4 equals 0. If we subtract 3 from both sides, we get x is equal to negative 3. If we add 4 to both sides, we get x is equal to 4. All right. We need to figure out if these are going to be removable or non-removable at this point. So we're going to go back up to our factored form of our equation. That's this equation right here. And we're going to look and see if we have any factors in the numerator and the denominator that we can cancel out. As we see here, we can't. There is no factor that is identical in the numerator and denominator, which makes both of these discontinuities non-removable. So we're going to just put an NR underneath them to just remind us of what those are. And because they are non-removable, they show up as vertical asymptotes in our graph. So we've got a vertical line at x equals negative 3. And we have a vertical line at x equals 4. All right. The next step is going to be what I call a sign chart. The reason why I call it a sign chart is because really nothing else goes on the chart except for signs. Every single time that we are building a sign chart, we're going to be putting two different things on there as numbers. One of those is our x-intercept. So we circle the x-intercept in our work and any non-removable discontinuities. So we've got two non-removable discontinuities. We're going to put all 3 of these on our sign chart. There is no x-intercept, so we're not going to put that there. non-removable discontinuities, though, we have -3 and 4. We're going to put those in order on our sign chart. So we have -3 and we have 4. The idea, the goal of the sign chart is we aren't looking at what's happening at -3 or 4 because we know what's happening at 3 and 4 because we have vertical asymptotes at -3 and 4. So we are instead looking to see what happens in between. What happens to the left of -3? What happens in between -3 and 4? And what happens when we're greater than 4? So at this point, we're just going to start choosing some numbers. We're going to take those numbers and we're going to plug them into our factors in our factored form. In this case, we have 3 factors, so we're going to have 3 different signs. And then we're going to look at those 3 signs and figure out if we're going to have an overall positive or overall negative part of our function. So we've got -3, and if I want to be less than -3, I'm going to choose something like -4, -5. It could be even -1,000. It doesn't matter. You're going to get the same answer. So if I plug in -5 into 3, for instance, I'm going to get 3. And that may seem confusing to you, so I'll explain that in a second. 3 has no variable. Because it has no variable, it stays 3. If I were to plug in, for instance, if f of x is equal to 3, then f of -5 is still equal to 3 because I'm not actually plugging in -5 into anything because I can only plug that into the variable, and there happens to be no variable. So 3. We're asking ourselves, is that a positive number or a negative number? In this case, it's a positive number, so we get a positive number. Just so you're aware, I organize my work in my sign chart by putting my numerator factors on top of the line and my denominator factors on the bottom of the line. You don't need to do this, but it is just an organizational strategy. So next I'm going to take the -5, I'm going to plug it into this x value here. So that'd be -5 plus 3. -5 plus 3 is still a negative number, so I'm going to put a negative there. And then -5 minus 4. -5 minus 4 is a negative number, so we end up with this. Okay, so we're going to look at these 3 signs real quick. We've got a positive and 2 negatives. Remember that positives don't change our overall sign, so really all we're doing here is counting our negatives. And if you have an even number of negatives, you will have a positive outcome. And if you have if you have an odd number of negatives, you're going to have a negative outcome. For instance, -1 times -1 is +1, but -1 times +1 is -1. So that would be the difference. Here, because we have 2 negatives, the overall sign will be a positive. Next, we choose a number in between -3 and 4. If you can use 0, always use 0. It's super easy to use. Same as before, plugging 0 into 3 just gives you 3. So we're going to end up with a positive value there. 0 plus 3 is positive, and 0 minus 4 is negative. Looking at these 3 signs again, we end up with 1 negative, which means an overall negative value. Lastly, I need a number larger than 4. Let's choose 5. So 3 again stays 3. 5 plus 3 is positive. And 5 minus 4 is still positive. So we've got 3 positives, which means 0 negatives, which is going to give us an overall positive value. Now these signs are going to tell us how our graph exists in our actual coordinate plane. I know that to the left of -3, to the left of this vertical asymptote, our graph is going to be positive, meaning that it's above the x-axis. It's above the x-axis, so the only place it can exist is right here. and we're going to draw it so that it approaches our asymptotes, both our horizontal asymptote and our vertical asymptote. Next, we've got between -3 and 4. That's going to be a negative, meaning it's below the x-axis, and it still needs to approach our asymptote. So it's going to look something like this. And lastly, whenever we're greater than 4, we're positive again. So that, again, is going to give us a graph that looks like this. So we're approaching our asymptotes, and we are staying either positive above the x-axis or negative below the x-axis. And that's it.